True story. I'm at dinner with a friend, and halfway through his pasta, he talks about how he thought he had a simple weekend project to work on, which was to make search feel smarter. Now, his goal was to continue using Postgres because he's familiar with it and add one plugin, pgvector for vector embeddings, and ship it by Monday. Sounds clean and sensible, right? Well, it does work for like 2 days, because when Wednesday comes along, that tiny loading spinner that everyone just loves is the main character. Support screenshots all look the same. He nudges a few settings, he rents a bigger box, pushes some jobs to a side worker, and then it finally calms down, but then it spikes again. A nightmare, right? And I feel like that's something that we're all too familiar with. So it's funny because on the table at Olive Garden, he pulls out his pen and sketches his sharding plan on the napkin. And we laugh out because no one wants to spend time doing shard math at Olive Garden, right? But here's the part I think that really matters. His plan wasn't necessarily wrong. Postgres on one machine is a tank, and pgvector is actually solid. The problem though is workload shape. Regular rows plus embeddings, bursty writes and spiky reads. Vector indexes get wide. You have housekeeping like auto vacuum and checkpoints, which competes with live traffic, so you see bloat, wall pressure, and stalls right when usage speaks. And replicas buy headroom, but add staleness. Now, cue upgrading windows, vacuum sprints, hand sharding, and reviews waiting on fresh data. That, folks, is the single box tax. Now, when I was at dinner with my friend, I actually played a game with him. I played the what if game because, I do work at TiDB. And I asked him, what if you have the same app, the same queries from the same developer seat, but a different foundation? What if storage split itself into ranges, kept 3 copies via consensus, and move hot ranges off busy nodes? What if the SQL layer were stateless so you can add capacity during a spike and remove it when traffic dies down? What if vector search, your vector search data, your vector embeddings lived inside the same database as your business data? It would include approximate nearest neighbor indexes you configure once, a distance metric you choose up front, and a planner that knows how to mix similarity with normal filters. No ceremony needed, no sidecar, and no napkin shard plan at Olive Garden. That, folks, is TiDB Cloud. Now, how does TiDB Cloud work under the hood? Well, I'm glad you asked. Well, requests land on a stateless secret layer. Okay, and then data lives in a replicate key value store for durability, and then as load shifts, hot ranges actually split and move, so no single key turns into a hotspot. And then when it comes to analytics, replicas actually use a columnar layout for fast scans, and then they read the same snapshot as transactional queries, so OLTP and analytics see the exact same truth. And when it comes to transactions actually provide snapshot reads and write isolation, which cuts down the "is a replica caught up yet" moments. And when the graph gets bumpy on a random Wednesday night, you add capacity by changing the topology rather than firefighting at midnight. Now, I can't be too biased because yes, I love TiDB, but I need to also talk about when does Postgres and pgvector make sense for you. For example, if your data fits comfortably in memory, traffic is predictable for you, and your team knows Postgres inside out, and index maintenance isn't a consistent chore, then stick with it. In that setup, pgvector is actually a great choice. You only need to think about a distributed system when I like to say the coordination tax shows up, which is like when auto vacuum can't keep up after a big write day, or replica lag is something users actually feel, or you're adjusting product plans just to work around database limits. But okay, let's get back to the what if game. What if the big change is not only performance, but it is how failures behave? What if my friend stops scheduling extension upgrade windows? What if he stops choosing between fresh reads and safe reads, or he stops waking up to rebalance a drifting shard? What happens is that the conversation actually shifts from how do we hide the spikes to how often does the tail cross the line when users notice? And now observability becomes intentionally boring. You keep an eye on slow queries and traffic spikes, and everything else should say quiet. And in this case, I think quiet is good. Now, one more thing. When should you not use TiDB? If your workload is batch first and staleness never blocks users, a warehouse with nightly jobs is fine. But if your app leans on Postgres specific features you cannot or do not want to replace, then stay with it. And if your team values a fixed monthly bill over elasticity, factor that in. But do not move because it is new. Move when the old plan starts charging interest in nights and weekends, right? So now let's go back to that dinner with my friend. He asked me, Chris, if distributed always means more complicated. Good question, right? I told him, sometimes it does. But here's the complexity you carry as a human gets smaller. You stop carrying extension lifecycles in your head. You stop carrying shard placement in your head. You stop carrying replica lag in your head. Instead, the system carries it for you, and the levers feel like product levers, not plumbing. So now let's say, what if he started his week with TiDB Cloud instead of Postgres and pgvector? Monday ships and stays shipped. Wednesday night does not page anyone, and Friday's review uses this morning's data, not last night's dump. The sprint ends with a new runbook, no fireworks, and just fewer bad surprises, and a team spending time on the features they meant to build. Anyway, I hope you enjoyed this video. If you want to try out TiDB Cloud, go ahead and make sure you check it out in the link in the description below, and use the TiDB starter plan where you get 5 GB of free data usage. Anyway, I'll see y'all next one. Peace.